Okay, I think I'm getting a little bit better at knowing how my computer is working here. So let's try one more, a little bit more difficult, for changing percent to an empirical formula. And in this case, the question is telling us to determine, okay, not working, I thought I was getting better, determine the empirical formula. So we're looking for an empirical formula, and we were given percents. So again, we're going to reach back into our memory banks, and we're going to pull out those three simple steps. Step 1, change percent to grams. Step 2, find the molar ratio by dividing by the atomic mass, which is also the molar mass. And step 3, divide through by the lowest product of step 2. So let's do this. Let's take, I'll write in blue, and let's write down everything we know. We know that we have potassium, and potassium was 24.74%. We know we had manganese, which is Mn, and we had 34.76%. And then we had oxygen, and we had a lot of that. We had 40.50%, and I got that straight from my problem. Step 1, change percent to grams. So I'm going to take the percent signs off by erasing them, and I'm going to stick grams on there. That's step 1. Step 2, divide by the atomic mass for the element that we are talking about, which will give us moles. So we're going to take 24.74 grams. We're going to divide it by what potassium weighs, round it to the nearest tenth, which is 39.1 grams per mole. Okay? If you do not know where that number came from, what I suggest you do is you take out your periodic table, which I will show you right now, and you look at potassium, which is right here, 39.09, and round that to the nearest tenth, 39.1. And when you get 39.1, that's the number that I put right here, 39.1 grams per mole. I'm doing the same thing for manganese. Manganese was, I need a pen, an eraser, 34.76 divided by what the atomic mass of manganese is in molar mass. So we're going to look up manganese, and we're going to find that it's 54.9 grams per mole. It's a 5. It's a bad 5, but it's a 5. And then finally we have oxygen. We're going to do the same thing. Oop, keep your units on there. 40.50 grams divided by oxygen's molar mass, which is grams per mole, 16 grams per mole. Okay, so now that's step 2. We just have to do the math. So break out your handy dandy calculators, and you'll find that this is 0.63 moles. This is 0.63 moles. And this one is 2.53 moles. All I did was plug these numbers into my calculator. When you're plugging numbers into your calculators, I want to make sure that you understand that the top number goes into your calculator first. So you would type in clear 24.74 divided by 39.1, and you'll get 0.63 moles. And then you're going to do the next one, 34.76 divided by 54.9, and hit enter, and you get 0.63. And then finally 40.50 divided by 16.0, making sure that you write the top number in your calculator first. You should end up with 2.53 moles. So that's step 2. Now step 3 says this molar ratio, 0.63 to 2.53, has to be in lowest whole numbers. They're not in whole numbers right now. Basically what you have, if I can write this small enough, we've got K with a subscript of 0.63. We've got Mn with a subscript of 0.63. And we've got O with a subscript of 2.53. Well, that's not an empirical formula because it's not lowest whole number ratio. So we need to divide each one of these by the lowest value. 0.63 divided by the lowest value out of all three of these numbers is 0.63, 0.63, and 0.63. Okay, again, more math in your calculator. This one should be easy. It's 0.63 divided by itself will give you 1. 0.63 divided by itself will give you 1. 2.53 divided by 0.63 is going to give you 4. Okay, if you end up with 0.25, you put it into your calculator incorrectly. So now we have K, not 0.63 anymore, but we have a subscript of 1, which I'm not going to write in because subscripts of 1 are understood. Mn with a subscript of 1, and O with a subscript of 4. It's a bad 4. Okay? It got worse. KMNO4. Okay? Now we have an empirical formula for the elements where the percentages were as follows. Okay? Everybody good? Okay, let's carry on.